Plasma Donation Processing Time, a project by Lisa Johnson for Kettering University. Interest in this study is based on the variation in plasma donor processing time because it is correlated with product quality, customer service, and continued donations. The goals of the study include determining the root causes of variation to improve product quality, customer service, productivity, and the company's image in the community. Quality in the plasma donation process is measured against customer service expectations. The company goal is to process donors through the entire process within 64 minutes of arrival. Some variation is allowed in the process. Specification limits are set at 3 minutes faster than average and 3 minutes slower than average. Maintaining a processing time within 6 minutes throughout the day allows donors to plan their donation appointment. Consistent duration of donation appointments is correlated with donor retention. Quality is also measured in terms of the product and process. Documentation errors often increase as variation in processing time increases. Process deviations are correlated with increased processing time. Errors in documentation and procedural steps can have a negative impact on the plasma collected by the facility. In some cases, plasma must be destroyed as a result of errors occurring within the process. The organization under review has competition in the plasma industry. Organization A, the focus of this study, advertises on their website that donors can expect a donation to take 45 to 60 minutes. Organization B advertises plasma donation appointments taking 60 minutes. Organization C advertises plasma donation appointments taking approximately 90 minutes. Organization A is currently advertising the fastest donation processing time. This is a competitive edge the company seeks to maintain hold of. The donation processing time begins when the donor checks in for their appointment by scanning their fingerprint in the facility. The donor completes a self-administered electronic donor questionnaire. Following the questionnaire, an employee must process the donor through medical screening. After the employee completes blood pressure, pulse, microhematocrit, and total protein readings, the donor is directed to the donation floor. At this point, a phlebotomist will perform venipuncture and connect the donor to the plasmapheresis device to begin the donation. When the donation is complete, the donor is disconnected by an employee, ending the donation processing time. Wait times in the process occur after the electronic donor questionnaire, before the donor is connected to the plasmapheresis device, and at the end of the donation when the donor is waiting to be disconnected. Each process step and wait time contribute to the overall processing time of the donor. The processing time is shortest when the donor has minimal wait times. Factors that contribute to the overall processing time can be categorized as donor-related, employee-related, or process-related. Donor-related factors include whether the donor has a pre-scheduled appointment and the hydration level of the donor. A pre-scheduled appointment allows the donor to begin their donation immediately upon arrival if they arrive within 10 minutes of their appointment time. Donors without an appointment are considered walk-ins and are scheduled by the system for the next available appointment. Plasma donation goes relatively quickly if the donor is well hydrated. Donors who drink an adequate amount of water the day before and the day of their donation typically complete the process quickly. Employee-related factors that contribute to the processing time include scheduled shifts and Washington state break laws. Due to Washington state labor laws, breaks must occur within specified time frames. To remain in compliance with the law, the facility may sacrifice donor processing times. Process factors contributing to processing time include the availability of equipment and the appointments available each hour. Equipment in need of repair cannot be used to process donors. If equipment is out of service, donors may need to wait to be processed using the remaining in-service equipment. The appointments available also contribute to processing times. If the number of available appointments is not balanced with donor show rates and labor hours, the processing time can be affected. Factors that can be controlled include the staff schedule, equipment availability, and donation appointments available. The staff schedule can be adjusted to meet the donor needs and patterns of donor arrival times. Equipment should be returned to service in a timely manner to facilitate all workstations being in use. The number of appointments available should be balanced with labor hours. The grace period to check in for an appointment can be managed by changing one setting in the donor information system. For this study, data is collected from the donor information system. The system saves timestamps at each step of the donation process. The processing time for each hour is calculated by averaging the processing time of all donors who begin the donation process each hour. Throughout the duration of this study, data is collected from a different facility in the network. Remote data collection reduces the influence the study has on the process. Data is sorted by date and time. The sequential data points show variation patterns. The data for this study spans the time frame of February 1 through March 5, 2016. Information not included in the process analysis is the actual number of donations processed by hour and the variation in target plasma volume of each donor. Throughout the day, donation levels vary from 15 to 70 donations each hour. The target volume of plasma is determined by the donor's weight. There is no control over how many donors of each weight classification complete a donation each hour. The specification limits are set by senior leadership. The average processing time goal is 64 minutes. The upper specification limit is set at 67 minutes, and the lower specification limit is set at 61 minutes. Some considerations associated with specifications include the individual experience of each donor. The target volume of plasma donated is determined by the donor's weight. Donors may donate 690, 825, or 880 milliliters of plasma. The specification limits are set in terms of the average processing time by hour, not the individual processing times of each donor. The current state of average processing time by hour is illustrated by this X-bar chart. Each point indicates an hour the facility was open for donations and the associated average processing time that hour. The average processing time for the time span of data collection was above the 64-minute goal at 65.34 minutes. The upper control limit of this data set was 73.22 minutes, and the lower control limit is 57.47 minutes. Data is characterized as either variable or attribute depending on what the data indicates about the process being observed. In this case, the data is measured on a continuous scale, making it variable data. Individual moving range charts allow the user to monitor the process center and variation when subgroups of the measurements are difficult. The process output provides a data point for each hour of the day, 6 days a week. The IMR chart allows the user to monitor the mean donation processing times and variation in donation times. Of the 237 data points collected from February 1st through February 20th, 24 points are out of control limits, and the process mean was not stable. A scatter plot can be useful to visualize changes in data over time. In this case, the data on the scatter plot shows that longer processing time occurred at the beginning of February. Investigation into potential related factors at the beginning of February revealed processing times above the control limit were correlated with an increase in employee sick time. Weeks with fewer employees out sick had average processing times with less variation by hour. The cumulative sum chart shows the deviations of data from the mean value. This chart can be used to identify drifts in the data over time. An increase over time occurs at the beginning of the data collection, then moves in the opposite direction toward the end of data collection. From the cumulative sum chart, the user can further investigate the data to determine why the cumulative sum of each deviation varies from the mean of the data. The target value in this chart was set as the process mean at 65.34 minutes and 1 standard deviation. Process capability refers to the uniformity of the process. The more uniform a process is over time, the more capable of delivering consistent products to the customer. The process capability ratio is determined by dividing the difference of the lower specification limit and the upper specification limit by 6 sigma. A CP that equals 1.0 is said to be meeting specification and is minimally capable. A CP that is less than 1.0 is outside the range specification and must be improved. Data collected for this process has a CP calculated as 0.29, indicating the process needs improvement. Process output data was entered into Minitab, segregating each date into groups to properly calculate process capability. To create the groups, each date was assigned a number. For example, data from the first date of collection, February 1, 2016, was assigned to Group 1. All points from February 2, 2016 were assigned to Group 2, and so on. The upper specification limit and lower specification limit were entered into Minitab, and the data in this figure illustrates the process outputs for the time period under review. Data collected is not centered on the target process mean of 64 minutes. The data set is off-center in the direction of the upper specification limit at 65 minutes. When the process mean is not centered between the lower specification limit and upper specification limit, more data points will fall outside the specification limits. To take into account processes that are not centered, the CPK is calculated. The CPK of the dataset is calculated as 0.19, which is less than 1.0, indicating the process is not capable. By the end of the study, data included 395 hours of operation, giving 395 data points. Of the 395 data points, 117 were outside the specification limits. To calculate the projected percentage of defective outputs, the number of defects is divided by the sample size, then multiplied by 100. This dataset has a calculated percentage of defective outputs of 0.29, or 29% of all outputs being defective. A process is said to be in control when 5% or fewer defects are witnessed in the process. Without improvement to the process, the projected defect rate will remain 29%. The capability of the process indicates the overall donation process is not in control, making it more challenging for the facility to meet all required metrics. A reduction in variation of total donor processing time would allow the leadership team to address other metrics, while also allowing donors to schedule and complete their donation in a consistent time frame regardless of time of day. To begin, the leadership team should schedule the maintenance technician's time each day to fix equipment and return it to service. Second, the leadership team should identify which hours of the day are consistently above the upper specification limit. Adjusting the staff schedule to accommodate the number of donors processed during those times should be the first step. Bringing the average of the busiest time of the day closer to the target of 64 minutes will bring the overall process average closer to 64 minutes and shift the data to be more centered between the upper specification limit and lower specification limit. The cost of changing staff schedules is minimal. Interview with the current scheduling supervisor indicates schedule adjustments are a routine occurrence for each schedule published, and more specific instructions would not add time to the current process. Donor appointment and arrival times can be monitored to identify necessary adjustments to appointment availability to match popular donation times. Observation of the process has revealed that many donors take advantage of the 10-minute grace period before and after their scheduled appointment time. The grace period of 10 minutes before and 10 minutes after an appointment time results in the possibility of 25 donors arriving at the top of the hour, even though only 5 appointment slots are available during each 5-minute period. The current grace period can create a bottleneck in the donation process due to not enough stations available to screen the donors. Reducing the grace period to 5 minutes before and 5 minutes after the scheduled appointment time would reduce the potential number of donors presenting for any given time slot from 25 to 15, which is more manageable given the number of processing stations. The cost of changing the grace period would be minimal due to one setting change in the manager's console of the donor information system. Donors who arrived outside the 5-minute grace period would simply be automatically rescheduled for the next available time slot by the donor information system. Review of donor information system data would provide the number of donors processed each hour. Plasma industry regulations require a ratio of 6:1 donors to phlebotomists. For every 6 donors, there would need to be 1 phlebotomist scheduled. To operate, the facility would need 1 nurse, 3 medical historians, and 1 sample processing technician minimum each hour. The maximum number of medical historians processing stations is 9, and there are 3 sample processing stations. If all stations and phlebotomy sections are in use, the minimum number of employees is 25. Historical data indicates donors typically arrive at the top of the hour and at half past the hour. Currently, employees arrive at the same time as donors. The staff schedule could be adjusted to require employees to arrive for their shift between 10 to 15 minutes before the donors typically arrive. The adjusted start time would allow employees to clock in, set up their workstation, and prepare to process donors. Adjusting the staff schedule would reduce the wait times between steps of the donation process that require staff interaction. The current out-of-service process lacks structure and accountability. There is no required time frame to repair equipment and return it to service. After determining the correct balance of employee schedule to donations by hour, service technicians would be scheduled to complete maintenance each day as part of the current 5S processes. Adjusting appointment availability should only occur after the scheduling and maintenance areas are fixed. If appointments are not available when the donor has time in their personal schedule, they will not be able to complete a donation. The appointments would first be adjusted to match the maximum number of donations possible each hour. The facility has 72 donation beds, which allows 72 donations per hour. There is an average deferral rate of 3% of donors who begin their questionnaire. Therefore, 75 appointments should be made available during hours when 25 or more employees are scheduled. Hours when fewer employees are scheduled will have appointments adjusted, but will not have fewer than 42 appointments available. The minimum level of 42 appointments is intended to allow donors flexibility in their scheduled appointments. The requirement to maintain at least 42 appointments each hour may require additional changes to the staff schedule to ensure 7 phlebotomists are available to monitor donors while they are connected to the plasmapheresis device. Process robustness refers to how closely to the target the process performs. The focus of the improvements is to plan ahead to meet donor needs and process capability. By planning for and controlling inputs during the popular donation times, the variation in processing time by hour will move closer to the process specification of 64 minutes average processing time. The proposed changes will be deemed acceptable after a monitoring period of 1 month with a minimum of 320 data points. More than 2 samples are required to determine if the process has improved. Typical donation patterns follow a monthly cycle where the beginning of each month typically experiences a dip in total donations, making improvements to processing time natural. As each calendar month progresses, the number of donations increases. If the average processing time improves and remains stable within the upper specification limit and lower specification limit, the changes will be deemed successful. If the average processing time either does not improve or the process exceeds the upper specification limit, the improvements will be deemed unsuccessful and further process improvements will be needed. The organization under review is currently an industry leader in terms of average donor processing time. Competing organizations will continue to improve their processing time, which will cause the organization under review to lose competitive edge unless continued improvements are made. The process improvements suggested by this study address donor processing time as well as other metrics, including error rates and productivity. Producing units of plasma with fewer errors and fewer labor hours translates to cost savings for the final customers, the patients relying on plasma-derived products to live normal lives. To maintain competitive advantage, change must begin with the focus on providing the donation experience expected by the donors. If donors are unable to donate as their schedule allows, they will not continue in the plasmapheresis program. Efforts to retain current donors and gain new donors will continue to provide adequate supply of plasma to the manufacturing facilities, in turn reducing the likelihood of a shortage of medications.